Hello friends. Next I'll take the examples and the Taylors and the Lawrence, which will be usually asked for the 5 marks. Okay, and these examples are different from the examples which I have taken in previous class. So in these examples we are using some standard series which are done already in earlier class, that is in Taylors as well as in Lawrence series expansion. We are using one of the geometric known series 1 upon 1 minus x. It is nothing but 1 minus x raised to minus 1. Okay, so that is equal to 1 plus x square plus x cube plus and so on. So I think this already you come across even in differential equations. You please remember this 1 minus x raised to minus 1. Just to write 1 plus, all minus will be there, all terms are plus with a power. Here it is 0, 1, 2, 3 and so on. Okay. Similarly 1 minus x raised to minus 2 will be there. It is 1 plus 2x plus 3x square and so on. But rarely you come across that. Usually you come across in most of the example this series. And this series is convergent. Okay, it tends to some finite number if mod x is less than 1. This already studied in B.Sc IV sem in the series. Similarly 1 upon 1 plus x, 1 plus x raised to minus 1, alternatively plus and minus you have to write. 1 minus x plus x square minus x cube plus and so on. So these two series you are using in getting the Taylors and Lawrence expansions. Okay. So in both series this x should be, mod of this x should be always less than 1. Suppose if it is more than 1, you have to make it. And you have to convert every factor in the form of 1 plus or minus. If it is any number, you have to take it outside and make it in the form of 1 plus or minus here. So it is 1 minus x plus x square and so on. So in both series, mod x should be less than 1. If it is more than 1, you have to convert for less than 1 and you have to proceed. So in the example, you come to know how you can convert. Okay, so I will take examples. So first, obtain Taylor series for f z e is equal to 1 upon z minus 2 into z minus 3 within mod z is equal to 1. This is the circle. Mod z is equal to 1 is the circle. In this region, the function is analytic. Okay, already you know that this 2 and 3 lies outside the circle mod z is equal to 1. Inside that it is analytic. So you can apply Taylor series. But here it is, if you apply f dash, f double dash, f triple dash at the point z is equal to 1, it is very difficult to get because of quotient and two factors are there. So in such examples, usually all the examples are of the same type. I will tell first the procedure. If the factors are more than 1, you please write first using partial fraction. Convert them for the fraction, only one factor in the denominator, and then, okay, only here one reason, there are 3 reasons. Mod z less than 1 equal to between 2 and 3 and more than 3, like that. So I within the circle mod z is equal to 1 they have given. So now you have to write given function f of z is equal to 1 upon z minus 2 into z minus 3. So you have to write by using partial fraction. A by z minus 2 plus b by z minus 3. Okay. So find the values of a and b. Already I told the procedure also. So denominator of a is z minus 2 means z equal to 2. You have to substitute in this, leaving this factor 1 upon, okay, 2 minus 1, 2 minus 3 minus 1. So value of a is minus 1 upon z minus 2 plus. Similarly, put z is equal to 3, leaving this factor 3 minus 2, it is 1. So it is 1 by 1, 1 itself. So 1 upon z minus 3 here. Okay. Therefore, f z is minus of 1 upon z minus 2 plus 1 upon z minus 3 here. Okay. So this is the first step in the examples of these types. Then you take the reason here. Okay. The reason is given, or the domain mod z is less than 1. Okay, within means inside the circle mod z is less than 1. So if mod z is less than 1, automatically mod z is less than 2, less than 3 here. These numbers you have to take. It is 2 and 3, whether it is plus 2 or minus 2, but mod of that will be always 2 only. So you are getting it is less than 2 also. So this implies mod z is less than 2 and mod z is less than 3. Okay, because the numbers are 2 and 3 here. Because I want to make this in the form of 1 minus x. Therefore, this implies which is less than 1 now? Mod by z by 2 is less than 1 and mod z by 3 is less than 1 here. So you have to make in the form of 1 minus x. So I can take here 2 this side. It becomes less than 1. This is also less than 1. Okay, everything should be made less than 1 here. Therefore, f z now, f z is minus is there 1 upon. So ಈಗ ಏನು ಮಾಡಬೇಕು, ಇದು 2 ಏನಿದೆಯಲ್ಲ ಅದನ್ನು ಹೊರಗೆ ತೆಗಿಬೇಕು. ಯಾಕಂದರೆ ಯು ಹ್ಯಾವ್ ರೈಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ 1 minus or plus x1. So what to do? Constant you take outside. Minus 2 you take outside. What is remaining here? 1. What is remaining in the next? Z by 2. That's why you have to make this is less than 1. Okay. Plus. In the same second, minus 3 is taken outside. 1 minus Z by 3. See, always what the constant should be there, please take it outside. Write in the form of 1 minus x here. Okay, therefore it is 1 minus z by 2, 1 minus z by 3. So this is now minus of minus plus 1 by 2. ಇದನ್ನ ಏನು ಮಾಡಬೇಕು, ಈಗ ಮೇಲ್ ತಗೋಬೇಕು. You bring it in the numerator. 1 minus z by 2 to the power minus 1 minus 1 upon 3, 1 minus z by 3 to the power minus 1. So ಈಗೇನು ಮಾಡಬೇಕು, ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬೇಕು 1 by 2. So you have to expand by using this formula. What you have taken 1 minus x raised to minus 1. So you have to write 1 plus z by 2, okay, plus z square by 2 square plus z cube by 2 cube plus and so on. And this minus 1 upon 3, 1 plus z by 3 plus z square by 3 square plus and so on. Okay, so this will be the series. So 1 by 2 into 1 minus 1 upon 3 into 1 minus 1 by 3. Okay, so 1 by 2 minus 1 by 3, you can get it is 1 by 6 plus z by 2, z is common, okay, taken outside, 1 by 2 minus 1 by 3 into 3, 9. Okay, 1 by 3 into 3, 9. 1 by 2 into 2, 4. Plus z square, 1 by 2 raised to 3 minus 1 upon 3 raised to 3 plus and so on. Okay, so this will be the series you are getting, or this is in the form of summation. F of z is, you are right, f of z 1 by 6 plus summation z raised to n. Okay, 1 by 2 raised to n minus 3 raised to n. N is from here, it is 2 square, means 2 to infinity. Okay, so this is the given required Taylor's series. Taylor's series about the point z is equal to 0, that is within the center, within the circle mod z is equal to 1. So this is with the positive power of z. So positive power of z ittandre it is always Taylor's. Positive and negative both are there, Lorentz, and even only negative powers are there, it is the Lorentz. So different reasons will be given. So this is for only one reason, mod within the circle mod z is equal to 1. Therefore it is only Taylor's expansion. And this question usually for the 5 marks they will ask, and different reasons they can ask here. Next. Next, second example. Expand the function, expand the function f(z) is equal to 1 upon z square minus three z plus 2 in terms of z in the region see here three regions they will give: mod z less than 1, second mod z greater than 1 less than 2, third mod z greater than 2 here. So three reasons will be given. Usually for the examination not three reasons they will give, only either one reason or the two reasons. So here I will take given function, see it is not given as a Taylor's or the Maclaurin's. In terms of powers of z means it is always either Taylor's or Maclaurin's. Given function is f(z) is equal to 1 upon z square minus 3z plus 2. Yes, what is this? This is 1 upon z minus 3, z minus 2, z minus 1. Okay, factors of this. So z minus 2, z minus 1. So this is what? 1 upon a upon z minus 2 plus b upon z minus 1 here. Yes, find the values of a and b. So put z is equal to 2 in this, except this one. So it is 1 by 2 minus 1, 1 itself. So a is 1 by z minus 2 plus put z is equal to 2 in this, 2 minus 1, it is again 1. Okay, sorry, z is equal to 2 I put, and this is z is equal to 1, put in this 1 minus 2 minus 1, and b is equal to minus 1 divided by z minus 1. Yes, I think all of you know already the procedure for getting partial fractions. Therefore f(z) is what? f(z) is 1 by z minus 2 minus 1 upon z minus 1. Ist correct madidre andre 1 marks. Okay, for getting partial fractions you are getting 1 mark. Then go with respect to the reason here. Okay, so first reason, when mod z is less than 1. Okay, so mod z less than 1 ಅಂದರೆ ಇದಂತೂ z minus 1 ಐತೆ, ನೀವು 1 minus z ಮಾಡ್ಕೋಬೇಕು. ಇದು z minus 2 ಐತಲ್ಲ, ಸೊ ಇದನ್ನು z minus 2 ಇದ್ದಿದ್ದು in the form of 1 minus ಮಾಡ್ಕೋಬೇಕು. 1 minus of that number should be less than 1 ಆಗಬೇಕು. So you what to do here? Mod z is less than 1 implies mod z is less than 2 also. Okay, therefore mod z less than 2 ಆದಾಗ mod z by 2 is less than 1. This implies mod z by 2 is less than 1 here. So now you have to make this in the form of 1 minus z by 2. Okay, therefore f(z) is 1 upon, ಈಗ ಏನು ಮಾಡಬೇಕು, minus 2 ಹೊರಗೆ ತೆಗಿಬೇಕು. Bring minus 2 outside. 1 is remaining for this. Okay, minus z by 2. So ಈಗ it is in the form of 1 minus x where mod x is less than 1. Then minus 1 upon, ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು, ಮೈನಸ್ ಹೊರಗೆ ತೆಗಿಬೇಕು. 1 minus z you are getting. So that this z is already less than 1 is there. So ಎರಡೂ less than 1 ಆಗಲೇಬೇಕು. 3 ಇದ್ರೆ 3 less than 1 ಆಗಬೇಕು. So in that way you have to express. So this is what? Minus of 1 by 2, 1 minus z by 2 raised to minus 1. Minus of minus plus 1 minus z raised to minus 1. So next your turn is to expand. Minus 1 by 2, expand it. 1 plus z by 2, z square by 2 square, plus and so on. Plus 1 plus z square plus z cube plus and so on. So ಎರಡನ್ನು ಕೂಡಿಸಬೇಕಂತ ಏನಿಲ್ಲ, not necessary to combine, you just write minus 1 by 2 summation z by 2 raised to n is from 0 to infinity, okay, because it is first term is 1 means put n equal to 0, 1 you are getting, put n equal to 1 z by 2 plus second one summation z raised to n is from 0 to infinity here. So it is over. This is required Taylor's series. ಯಾಕಂದ್ರೆ powers of z both are positive here. This is for one reason. Next reason. Second reason is given what? Mod z more than 1 less than 2. Okay, within analysis reason. Mod z more than 1 less than 2. Okay. So in this reason also the function is analytic. Because 1 is also removed, 2 is also removed there. Therefore you are getting this. Mod z less than, under this is the circle with radius 1 unit. And this is the circle with the radius 2 units. Okay. So this is the analysis reason. In this the function is analytic. Okay. In this reason. So now we can ಮಾಡಬೇಕು mod z more than 1 less than 2 means what? That is mod z more than 1 here. Okay. And mod z less than 2. So ಇವನ್ನೆರಡನ್ನೂ less than 1 ಮಾಡ್ಕೋಬೇಕು. So mod z more than 1 ಆದಾಗ 1 by mod z is less than 1. Okay. But mod z by 1 is again still more than 1 you are getting. So it is 1 by mod z is less than 1. Okay. And ಇಲ್ಲಿ mod z by 2 is less than 1. So please see here. Mod z is more than 2 ಇದ್ರೆ ಏನಾಗತ್ತೆ 2 by mod z is less than 1. Okay. So here it is mod z is more than 1 means 1 by mod z is less than 1. And mod z is less than 2 already there in previous also. It is mod z by 2 is less than 1. So here for the first factor, therefore f z is what? Yes, f z is 1 upon z minus 2. ಈಗ ನೀವು minus 2 ಹೊರಗೆ ತೆಗೆದ್ರೆ ಅಂದರೆ 1 minus z by 2 ಆಗ್ತದೆ. But z by 2 is not less than 1 in this case. It is more than 1. So ಈಗ ಏನು ಮಾಡಬೇಕು? Yes, here you bring z outside. Okay, sorry, in this it is z minus 2 will be there. It is correct. You have to take only minus 2 outside. You can get z by 2 because z by 2 is already less than 1 will be there. First factor. Okay. Therefore here it is same. First same as the previous one. Minus 2 is taken outside. 1 minus z by 2 because it is already less than 1. Okay. But for the next one. Next is what? See. Next is minus of 1 upon z minus 1. ಇಲ್ಲಿ minus 1 ಹೊರಗೆ ತೆಗೆದ್ರಿಂದ 1 minus z ಆಗ್ತದೆ. But mod z is more than 1 you are having. So you want less than 1. ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? ಈ z ಹೊರಗೆ ತೆಗಿಬೇಕು. You bring z outside. Remaining is 1 minus 1 by z. So 1 by z is already less than 1. Therefore you have to write minus of 1 upon z, you bring it outside, 1 minus 1 by z. Why? Because mod of this is already less than 1 in this reason. Therefore it depends on the reason here. So this is equal to minus 1 by 2. And already I have done in the previous case. This is summation of z by 2 raised to n. So first I am not going to write it in detail. Summation z by 2 raised to n minus 1 upon z into 1 minus 1 by z raised to minus 1. So this is minus 1 by 2 summation z by 2 raised to n minus 1 upon z. Again it is 1 minus x raised to minus 1 form. So expand it. 1 minus 1 plus x 1 by z plus x square 1 by z square plus and so on. Okay. Yes, this is what? This is same minus 1 by z summation 1 by z raised to n. n is from 0 to infinity. So this is Lorentz series. So here it is positive power and this is negative power. Okay. So this is Lorentz. Because I have given in the last class the statements of Lorentz and Taylor's and Lorentz. In the Taylor's you are having only positive power. In the Lorentz you are having both positive and negative here. So this is for the reason mod z more than 1 less than 2. Then third case when mod z is more than 2 here. Okay. So mod z more than 2 atandre automatically mod z more than 1 age bidutade. So this implies mod z is more than 1. So which are less than 1 then? So this implies. So again ಮಾಡಬೇಕು 2 by mod z is less than 1. ಈ z ನು ಈ ಕಡೆ ತಗೋಬೇಕು. So this implies 2 by mod z is less than 1 and 1 by mod z is also less than 1. So third case ಒಳಗೆ ಯಾವಾಗಲೂ z ಹೊರಗೆ ತೆಗಿಬೇಕು. ಎರಡು ಫ್ಯಾಕ್ಟರ್ ದಿಂದ z ಹೊರಗೆ ತೆಗಿಬೇಕು. So you can get 2 by z and 1 by z. Therefore what is f of z? Therefore f of z is, see for this factor here also you take z outside. Okay. Therefore you are getting 1 upon z, you bring it outside, remaining is 1 minus 2 by z. Why? 2 by z is less than 1. And for the next one minus, again z is taken outside, 1 minus z. Okay, because z minus 1 will be there, bring z outside, 1 minus z. Sorry, 1 minus 1 by z. Okay, 1 minus 1 by z here. So that this is also less than 1, this is also less than 1. So you have to expand it. So I told already that in 1 minus x or plus x, if x is not less than 1, you have to convert. Okay, therefore this is 1 by z, 1 minus 2 by z raised to minus 1, minus 1 upon z, 1 minus 1 by z raised to minus 1. So this is 1 by z summation, or you can expand it. Okay, I will expand that. 1 plus 2 by z plus 2 square upon z square plus and so on, minus 1 upon z, 1 plus 1 by z plus 1 upon z square plus and so on. Okay, so this z, if you bring it inside, it is 1 by z plus 2 by z square plus 2 square by z cube and so on. So that will be what? Summation of 2 raised to n z raised to n plus 1. n is from 0 to infinity, minus summation 1 upon z raised to n. n is from, or n plus 1, n is from 0 to infinity. So this is again Lorentz series, or it is in the form of power of z. Here you are getting both are negative powers, it is in the denominator. Okay, so this is second example. So usually in this way if we will mention all the 3 reasons, and usually for the examination all 3 reasons they will not give. Okay, either only 2 reasons or 1 reason they will give. Which reason they have given, according to that you have to please write the function. Usually for the mod z less than the first factor, in both factors you should take constant outside. In between the 2 numbers you take for the first factor z outside, for the second factor as it is. For the last reason you take z outside for both the factors here. Okay, So next example I will take. Third one. See, if you solve the more and more examples, then you come to know the procedure. So the previous example is asked, this one is asked many times for 2011 and for 12 and 15. 12 and 15 for the 5 marks. Okay? But not all the 3 reasons. Either 2 reasons or 1 reason, but I have taken only 3 for your convenient. Next one. Obtain Taylor's expansion for the or Lorentz expansion for the function f of z is equal to, for the function f of z is equal to z square minus 1 divided by z plus 2 z plus 3, z plus 2 z plus 3 when first reason mod z is less than 2, second reason mod z more than 2 less than 3, third reason mod z more than 3. This is asked for 2013. Only these 2 reasons are asked. This is not there, but I have taken this reason also. This is asked for 2013 here. Yes, solution. Yes, directly you don't go for the partial fraction because this fraction is improper. Degree of the numerator is same as degree of the denominator. So you divide first. You divide z square minus 1 by z square plus 5z plus 6, and then you get quotient and then for the partial fraction. So now z square minus 1 divided by z plus 2 z plus 3 can be written as, see how to divide it, z square minus 1 and this product is z square plus 5z plus 6. So z square into 1 z square, so 1 into 5z 1 into 6 6. So you can subtract minus 5z minus 6 minus 1 minus 7. Therefore this is equal to 1 minus 5z plus 7 divided by z plus 2 z plus 3. Okay, so you have to get partial fraction only for this function. If it is improper fraction, make it is proper. Sometimes they will ask the questions on this also, and but most of the examples are in the form of a proper. This I can write a by z plus 2 plus b by z plus 3. So get the value of a and b. So again ಇದನ್ನು ಬಿಟ್ಟು ಬಿಡಬೇಕು ಈ ಕಡೆಯಿಂದ. You consider only this. To get the value of a, z is equal to minus 2 ಹಾಕಬೇಕು. You leave this. ಇದನ್ನು ಬಿಡ್ರಿ. ಇದನ್ನು ಬಿಟ್ಟು ಉಳಿಕಿದ್ರೊಳಗೆ z equal to minus 3 ಹಾಕಬೇಕು. So how much you are getting? Z equal to minus 3 means minus 15. Okay. Yes, this is minus 15 and plus 7 divided by z is equal to 2 you have to substitute, not 15. Minus 2 you have to substitute, minus 10. Minus 10 plus 7 divided by minus 2 plus 3, 1. So you are getting minus 10 plus 7 is equal to, that is minus 3. Therefore 1 minus 3 by z plus 2. So once again we check it. Then for z is equal to, we have to get z equal to minus 3, you substitute leaving this factor. Minus 3 plus 2 minus 1, minus 15, minus 15 plus 7, okay, minus 8. Minus 15 plus 7 is minus 8 divided by, it is minus 3 plus 2 minus 1. So minus minus plus 8. So you are getting this is plus 8 by z plus 3. Okay, therefore this is 1 minus of minus plus 3 by z plus 2 minus 8 by z plus 3. Yes, I hope you followed it. And this is f of z now. So either you have to be very fast in getting the values of a and b. Next, consider the reason. First one, when mod z is less than 2. ಯಾವಾಗಲೂ ಇವೇನು ನಂಬರ್ಸ್ ಇರ್ತಾವಲ್ಲ ಅದೇ ನಂಬರ್ಸ್ ಕೊಡ್ತಾರೆ ಅವರು. ಫಸ್ಟ್ ಒನ್ ಆಲ್ವೇಸ್ ಫಾರ್ ದಿ ಸ್ಮಾಲರ್ ನಂಬರ್, ಸೆಕೆಂಡ್ ಈಸ್ ಬಿಟ್ವೀನ್ ಸ್ಮಾಲರ್ ಆ್ಯಂಡ್ ಗ್ರೇಟರ್, ಲಾಸ್ಟ್ ಒನ್ ಈಸ್ ಫಾರ್ ಗ್ರೇಟರ್ ದನ್ ಗ್ರೇಟರ್ ನಂಬರ್. ಸೊ mod z ಲೆಸ್ ದ್ಯಾನ್ 2 ಆದಾಗ ವಿಚ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 1, mod z ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 3 ಆಲ್ಸೋ. ಲೆಸ್ ದ್ಯಾನ್ 2 ಇತ್ತಂದ್ರೆ ನಂಬರ್ ಲೆಸ್ ದ್ಯಾನ್ 3 ಆಗಲೇಬೇಕು. ಒಂದು ನಂಬರ್ ಯು ಟೇಕ್ 1 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 2, ಇಸ್ ಇಟ್ ಲೆಸ್ ದ್ಯಾನ್ 3? ಎಸ್. ಸೊ mod z ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 3 ಆಲ್ಸೋ. Therefore which are less than 1 then? Therefore mod z by 2 less than 1 and mod z by 3 less than 1 here. So ಎರಡೂ less than 1 ಮಾಡ್ಕೋಬೇಕು. Therefore what is f z now? f z ಈ ಕಾನ್ಸ್ಟೆಂಟ್ 1 ಹಂಗೆ ಬರೀಬೇಕು, ಪ್ಲಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ 3 ಹಂಗೆ ಬರೀಬೇಕು. ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು? 2 ಹೊರಗೆ ತೆಗಿಬೇಕು. ಯು ಬ್ರಿಂಗ್ 2 ಔಟ್ಸೈಡ್. ವಾಟ್ ಈಸ್ ರಿಮೈನಿಂಗ್? 1 ಪ್ಲಸ್ z by 2. So you have to get in the form of this. Okay, next minus 8, ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು? 3 ತೆಗಿಬೇಕು. 1 ಪ್ಲಸ್ z by 3. ಯಾವಾಗಲೂ ಫಸ್ಟ್ ರೀಸನ್ದೊಳಗೆ 2 ಫ್ಯಾಕ್ಟರ್ಸ್ ಇರಲಿ 3 ಫ್ಯಾಕ್ಟರ್ಸ್ ಇರಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಹೊರಗೆ ತೆಗಿಬೇಕು. ರೈಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ 1 ಪ್ಲಸ್ z by that constant. Okay, in another also that 1 plus or minus you are getting. Next you bring it in the numerator. ಇಲ್ಲಿವರೆಗೆ it is very easy after this. 1 plus 3 by 2, 1 plus z by 2 raised to minus 1 minus 8 by 3, 1 plus z by 3 raised to minus 1. So you expand it. 1 plus 3 by 2. So 1 plus x formula ಇಲ್ಲಿ. x ಅಂದರೆ 1 ಪ್ಲಸ್ ಇದ್ದಾಗ ಆಲ್ಟರ್ನೇಟ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ z square by 2 square minus z cube by 2 cube plus and so on, and minus 8 by 3, 1 minus z by 3 plus z square by 3 square minus and so on, minus and so on you have to write. So ಈಗ this is 1 plus 3 by 2, write summation. Alternative ಪ್ಲಸ್ ಮೈನಸ್ ಇದ್ದಾಗ ಮೈನಸ್ 1 ರೇಸ್ ಟು ಬರೀಬೇಕು, ಮೈನಸ್ 1 ರೇಸ್ ಟು n ಮೈನಸ್ 1 ಬರೀಬೇಕು. z by 2 ರೇಸ್ ಟು n you have to write, because z by 2, z square by 2 square, z cube by 2 cube, it is 1 means 0, n is 0 to infinity. ಓಕೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ 0 ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು, ಇದಿತ್ತಂದ್ರೆ 1 ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ minus 8 by 3 summation minus 1 raised to n minus 1, z by 3 raised to n. n is from 0 to infinity. So this is the Taylor's expansion where both are positive here. Okay, both the factors you got positive in this. Then second, yes, second one, second reason, when mod z is more than 2 less than 3. What is that? Yes, mod z is more than 2 less than 3 here. So this implies what? Mod z is more than 2 and mod z less than 3. So mod z more than 2 adra which is less than 1? 2 by mod z is less than 1. ಸೊ ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಕೇಸ್ದೊಳಗೆ ಫಸ್ಟ್ ಫ್ಯಾಕ್ಟರ್ಗೆ ಯಾವಾಗಲೂ ಝೆಡ್ ಕೆಳಗೆ ಬರಬೇಕು. ಓಕೆ, ಆ್ಯಂಡ್ ಈಸ್ ಸೇಮ್, ಆ್ಯಂಡ್ ಮಾಡ್ ಝೆಡ್ ಲೆಸ್ ಬೈ 3 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 1. ಓಕೆ, ಐ ಹೋಪ್ ಯು ಫಾಲೋಡ್. ಸೆಕೆಂಡ್ ಸೇಮ್ ಉಳಿತೈತಿ, ಫಸ್ಟ್ ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗ್ತೈತಿ. ದಿಸ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ 2 by mod z. ದೆನ್ ಎಫ್ ಝೆಡ್ ಈಸ್ ವಾಟ್? ದೇರ್ಫೋರ್ ಎಫ್ ಆಫ್ ಝೆಡ್. ಓಕೆ, ಎಫ್ ಆಫ್ ಝೆಡ್ ಈಸ್ 1 plus 3 by 2, 3 by z plus 2. ಇವಾಗ ಏನು ಮಾಡಬೇಕು? ಇಲ್ಲಿ z ಹೊರಗೆ ತೆಗಿಬೇಕು. ಇದು ಸೇಮ್, ಇದು ಇಲ್ಲಿ 3ನೇ ಹೊರಗೆ ತೆಗಿಬೇಕು. ಇದ್ರಾಗ ಆ್ಯಸ್ ಸಿಮಿಲರ್ ಟು ದ್ಯಾಟ್ ಯು ಪ್ಲೀಸ್ ಟೇಕ್ 3 only outside, 1 plus z by 3, but ಇಲ್ಲಿ z ಹೊರಗೆ ತೆಗಿಬೇಕು. Okay, so it is 1 plus 1 plus 3 by z, you take it outside, 1 plus 3 by z. Okay. Sorry, not 3, it is 2 there. It is 1 plus first factor z plus 2 it is. So it is 2. So it is 2 is z is taken outside, 1 plus 2 by z and minus 8. So here you take 3 outside, 1 plus z by 3 only. Second will not be changed. Okay. So it is 1 plus 3 by z, 3 by z, 1 plus 2 by z raised to minus 1, minus 8 by 3, 1 plus z by 3 raised to minus 1. Okay. So this is what? 1 plus 3 by z, 1 minus 2 by z plus 2 by z whole square minus and so on. This is same as a previous one. So ಇಲ್ಲಿ ಏನು ಮಾಡಿಬಿಡ್ತೇನೆ ನಾನು, same as second is there. So minus 1 raised to n minus 1 and z by 3 raised to n I will write directly because already you solved it in previous case. ಅದಕ್ಕೆ ನೀವು ಸೇಮ್ ಇರೋದ್ರಿಂದ ಅದನ್ನೇ ಬರೆದು ಬಿಡ್ಬೋದು. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಈಗ, what you get here 3 by 2. This is minus 1 raised to, sorry, this is z not 2, 3 by z summation minus 1 raised to n minus 1 and 2 by z raised to n. N is from 0 to infinity minus 8 by 3 summation minus 1 raised to n minus 1 z by 3 raised to n. N is from 0 to infinity. ಯಾಕಂದರೆ ಇಲ್ಲಿ 0 ಹಾಕಿದ್ರೆ ಅಂದರೆ minus 1 raised to, sorry, it is n minus 1 ಅಂತಂದ್ರೆ not 0 you are getting. This is n itself because minus 1 raised to 0 is plus 1 you are getting. Okay, otherwise you can write it is n only, not n minus 1. Okay, because n itself you write 0 means you are getting minus 1 raised to 0 is equal to plus 1. Otherwise you write here 0, negative power you are getting. So it is not minus 1. So in previous example also I think this is not minus 1. Okay, it is just n. Yes, you please make it correction. It is not minus 1. It is just plus 1. If it is minus 1 raised to plus 1 minus 1 plus 1 minus 1 it has come, you have to write power minus 1 raised to n. Okay, otherwise n plus 1 you should write. So this is the series. Yes, I am writing once again 1 plus. ಈ z ನೀವು ಒಳಗೆ ತಗೋಬಹುದು. You bring it inside, writing constant outside. Summation minus 1 raised to n, 2 raised to n, z raised to n plus 1 ಆಗ್ತದೆ. Because 1 power z will be added here for the denominator. So it is z into z raised to n, n plus 1. N is from 0 to infinity. Minus 8 by 3 summation minus 1 raised to n, z by 3 raised to n. N is from 0 to infinity. So this is Lorentz expansion. Third one, when mod z is more than 3. Third reason, mod z more than 3 means what? Outside the circle mod z equal to 3, exterior. So mod z greater than 3 implies what? Mod z is greater than 2 also. Okay, ಈಗ ನಂಬರ್ ನೀವು 5 ತಗೋತೀರಿ ತಗೋರಿ, 5 is more than 3. Is it more than 2 also? Yes. Therefore which are less than 1 then? In both 3 by mod z is less than 1 and 2 by mod z is less than 1. So last reason ದೊಳಗೆ ಎರಡೂ ಕಡೆ z ಕೆಳಗೆ ಬರಬೇಕು. Okay, therefore f z is what? f z is s is same. ಇದು ಸೇಮ್ ಬರ್ತದೆ. ಓಕೆ, ಇಲ್ಲಿ z ಔಟ್ಸೈಡ್ ತಗೋತೀರಿ, ಇಲ್ಲಿನೂ ಏನು ಮಾಡಬೇಕು, z ಹೊರಗೆ ತೆಗಿಬೇಕು. 3 ತೆಗೆದಿದ್ರಲ್ಲ, ಈಗ z ಹೊರಗೆ ತೆಗಿಬೇಕು. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ 1 plus 3 by z, 1 plus 2 by z, okay, and minus 8 by z, you take it outside, remaining is 1 plus 3 by z, okay. So this is, you refer Fz only, starting what I have written Fz, that 1 plus 3 by z, 1 plus 2 by z raised to minus 1, minus 8 by z, 1 plus 3 by z raised to minus 1. ಸೊ ಎಲ್ಲ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಆಗಿರ್ತೈತಿಲ್ಲ, ನೀವು ಬರೆದು ಬಿಡ್ಬೋದು ಡೈರೆಕ್ಟಾಗಿ. 3 by z, ಇಟ್ ಈಸ್ ವಾಟ್, ಸಮೇಷನ್ minus 1 raised to n into 2 by z raised to n. n is from 0 to infinity. Okay. ಇಲ್ಲಿನೂ ಹಾಗೆ minus 8 by z summation minus 1 raised to n and 3 by z raised to n. n is 0 to infinity. So ಇಲ್ಲಿನೂ z is in the denominator, here also z is in the denominator, so it is a negative power. So you can say that this is again Lorentz series. Okay, so Lorentz series for the reason mod z more than 3. This is also Lorentz series. One power you are getting positive here. This is positive power, but this is negative power here. Okay, so in this way you can get Taylor's and Lorentz series for the examples, and I hope these examples are sufficient today. In the next class I will take the other type of the examples. Okay, I conclude now today's lecture. So still then, you please be safe at home and healthy at home.